we'll do the networking sessions where we can know each other's or have some gossips. And before we begins, I have a short announcement to make. We have created a GitHub repo which contains the curated list of DevOps resources. Please feel free to go through that. You'll find awesome resources there. You can contribute if you want to, and you will get the link in the chat box. Someone will post there soon. So today we have a special female guest for the first time, and we expect more females participants in the future too. So she is Adi Polak, a software developer at Microsoft, specialized in big data workloads such as analytics and machine learning at scale. So without further ado, let's start. So over to you, Adi.
Thank you so much, Sarah. It's wonderful to meet everyone. I was never in Kathmandu, and I looked at a few pictures, and it looks amazing. So beautiful and pretty. Okay, I'm gonna share my screen. Let me know if you can see it. Just a second. All right. Do you get the visuals? Is it working?
Nope. Not yet.
Not yet.
Yeah, it's working. Yeah, we can see.
Can you see the presentation?
Yeah.
Okay, cool. So today's session, we're gonna talk about bursty workloads or burstable workloads, and how we can think about cost and what criteria we need to think about when we are working with burst workloads. So a few of the things we're going to cover today. We're going to talk about different architecture decision making. What is the decision process around it, and why we should think about distributed systems sometimes. What are the various workloads that we're facing, not only burst workloads. We're going to speak about Azure Kubernetes Service. It's a managed Kubernetes service. ACI, the Azure Container Instance, and the open source Virtual Kubelet. What is not covered today, and all of these are huge topics that needs their own time, and we're not going to cover it today. We're not going to cover compliance. We are not going to cover container secure access, namespaces configurations, CI/CD pipelines, health management, and log collection analytics. These are very important topics when we work with distributed systems and in general when we create systems. But again, it deserves their own space. So the scenario for today, we're going to talk about e-commerce. And e-commerce is very interesting, especially today with Corona, that a lot of the commerce, the real commerce, goes online. All the shops, even the small ones, are now looking for a way to start selling their products online and to start shipping their products to people. So this is a very interesting scenario. And it's not the first time that people are doing e-commerce. I mean, we have huge e-commerce in the world, and we're going to look into them and understand a little bit what it means to work in an e-commerce space. A little bit of our architecture system design. When we start to think about our architecture, there's a lot of decisions that we need to do. We need to think about required guarantees. We need to think about known paths, if there are certain technologies that we already worked with in the past or not. Do we have the existing skills, or do we need to skill up and learn something new? Do we have the resources? Do we have the people? Do we have the place? Do we have the right tools? Another one is, what are the acceptable risks that we are willing to take in our system? If we're building a system, we know sometimes good enough is just right. We don't have everything to be perfect. So we need to understand what are the acceptable risks that we are willing to have in our system. And another important one is cost. We should always be cost efficient as much as we can, because we want to produce profit, and we want to have, at the end of the day, we want to make sure we're making profit and not just paying for the whole infrastructure. Some more decision-making variables that we need to think about. Again, resource time. What are the new things that I need to learn? Do I know how to troubleshoot if there's a problem? Do I know how to maybe profile my system sometimes to better understand what's going on in my systems? Do I need to be independent from a cloud provider, or is it okay for me to work with one dedicated cloud provider or environment? What is the consistency, the performance, the availability, maybe other guarantees that I have to provide? What is my readiness and the team readiness to accept possible risks? What is the level of system flexibility that I want to have? Sometimes too much flexible means a lot of maintaining. Maybe I want to work with something that is less flexible, but I already know that what it does well. So there's a lot of decision-making variables. And there's some decision-making best practice and questions that we can ask ourselves when we decide to architect system or to migrate the system. For example, what are the downsides and challenges of the current system that we work with? What environment to consider for running our system? What are we running on a Linux machine? Are we running on a Windows machine? What is the environment? Where do we live? What kind of problems will switching systems going to solve if I am going to do some migration or I'm going to build something from scratch? What the systems that I'm bringing in are, what they're good for, what their pitfalls, pros and cons, the new problems that they might create. How big will the increase or decrease in the cost will be? It's also a very important topic. What team processes change need to happen? Maybe I need to hire more people. Maybe I need to skill up some of the team because now they want to learn, they need to learn Kubernetes, for example. So there's a lot of decisions I need to make when I'm architecting a system. For example, if I'm architecting an e-commerce, this is our scenario for today, I need to think about web app services. I need to understand what kind of web app services I want to work with, what cloud providers I want to work with, maybe third-party providers. Each cloud today provide usage of third-party as well, so we can deploy them on any cloud. What about open source solutions? There are many open source solutions. There are a huge community around different open source platform and frameworks. Maybe I want to leverage that, but what does that mean? And this all brings us to the world of distributed systems. Because when we work with e-commerce and we want to scale, we want to be able to provide to all our customers. Some of the motivations that we want to do is we want to make sure our system is highly available, because sometimes downtime can cost us a lot of money, and we're going to see some use cases around that. We need to be able to scale. We need to be able, if we're now serving 100 people, maybe in the future we're going to serve 1 million people. We need our system to be reliable, reliability. It's super important for us that the system will be reliable, because if the system is not producing the correct output, it might impact our customers. It might impact how our customers view us. And then we need to think about transparency. The customers shouldn't know that there are distributed systems in the infrastructure, that we build their system on distributed systems. It should be transparent. They shouldn't be able to feel it. And when we work in the world of e-commerce, we usually look at two different workloads. We look at burst workloads. It's workloads that that produce some peak in my income traffic, and there are steady workloads where I know it's going to be the same for the next year, and then there's going to be some peaks along the year and specific days. And today we're going to focus on burst workloads. So what is availability and how much availability costs? So this is an article from 2018 that the Washington Post produced, and say that basically having a system that is available can translate to great profit and great revenue. Just for example, on Thanksgiving 2017, people spent $3.7 billion on purchasing things online. On Black Friday, people spent $6.2 billion on shopping online. On Cyber Monday, $7.9 billion. And there's also single day and more other days that makes people go online and shop more. So when we look at availability, this is super critical because we want to be able to provide on those days. We want to be able to to build a system that will be able to be available on those specific days that people are rushing to shop online. And also Business Insider talked about it as well. And in 2018, they estimated 3.6 million shoppers, which means that I might need to support 3.6 million sessions to my e-commerce. And what happened if I'm not available? Well, I'm going to lose money because I'm going to lose the opportunity here to serve my clients and to sell them. So being unavailable can be translated to losing profit and losing revenue. And we can cite a lot more people, but when we break it down, we need to be able to have multiple active instances that are available and that are able to scale. And what about latency? How fast should my system respond to every request? When we talk about latency, we usually refer to performance, and performance refer to user experience. And user experience translates to profit and loyalty. When people get good user experience, they tend to stay with the system, even if it means they're going to pay slightly more. When they get a good service, they prefer to pay slightly more sometimes and stay with the system that gives them a good experience, and that makes them a loyal customer. Just for example, this is an article for 2012. Today, the numbers are much higher, but 1 second of Amazon being down could potentially cost it $1.6 billion in sales. And again, this is from 2012. Today, the numbers are different, especially with the pandemic. Another example from Walmart. So Walmart did a research and discovered that if they improve the user experience and they reduce the latency from 4 seconds to 1 second, they actually have more shoppers that are finishing their shopping online. And if the other way is around, if it takes 4 seconds now to shop in their store, they're actually losing shoppers and less people are going to buy on their e-commerce site. So this is another important thing to understand when we think about latency and performance. So the main goal for us is to think about how we can best serve our clients. This is our business goals. But we also want to be cost efficient. This is our revenue goals. We want to build a system that's going to best serve our clients as well best serve our revenue goals and our profit goals. Let's take a look on one burst load scenario. Let's say I have Thanksgiving Day or Black Friday Day, and I know I have 1 day of known burst workloads that I need to support every few months. Let's say I need 200 machines with 1 core and 2 GB RAM for each machine. That should be something that it's sufficient for me. So 1 day translates to 86,400 seconds. And the options I can hold extra VMs for known burst workloads, which means I will have to pay for the extra VMs and manage them. I can maybe leverage something called cluster autoscale that maybe you've heard about from the Kubernetes world. I can maybe leverage something around scalable container instances that we're going to touch a little bit more. And another option for me is to switch offline workloads. And offline workloads are usually analytics and everything that I'm doing in batch processing and online and the offline to something called spot instances. And spot instances are cheaper VM instances that we can use in the cloud. So I can transfer my offline workloads to a spot instances if they're not already there, and then leverage the VMs that I already have, the known, the highly available, the VMs that I can trust. However, it might be hard for the operation, and it might be error prone as well. Just as an example, I took that scenario and I inserted into the cost calculator. So when I'm looking at container instances, the cost for it came up to 237.12 US dollars, and everything I did was in the region of the East US. It's important to understand that each region has different prices for different services, but let's say my customers and let's say my business operates in the US. So I want my services to be deployed in the US. So this is an example of how we deploy it in the US, and this is the breakdown of the cost. And then another option that I have is to work with VMs, to add new VMs. And adding new VMs cost me 288 US dollars, which means slightly more. I'm going to pay more. So the ACI solution, working with a container instance, might be a better use case for me. Just zooming into seeing everything that we put there, a Linux machine with the dedicated cores and the RAM. It is important to notice that when I work with virtual machine, I do get temporary storage that I don't get with Azure Container Instances out of the box. However, when I work with burst workloads, most often I'm probably not going to use a temporary storage. Most often I would like to write to something that is highly available, maybe MySQL, maybe Redis, something like that I can later on query it and read from that. Working with temporary storage, probably not going to cut it and not going to be enough for me for that use case. So after we agreed that we want to work with distributed systems, and we're probably going to have multiple VMs, if it's a managed container instances or other VMs that I want to spin out for my workloads, I need to take care of multiple things. I need to take care of the VMs that I'm working with. I need to take care of the containers that I'm working with, the network, the security, and the deployment of everything. And this is very hard. This is why we have Kubernetes. And Kubernetes is an open source container orchestration systems that automate the whole process of deployment, scaling, management. And it's built for distributed, scalable microservices architecture. So this is kind of the world where we are, microservice architecture. And when we think about Kubernetes, it has a lot of advantages. It can run anywhere. So I can have a Kubernetes service, Kubernetes cluster, and I can deploy it on any cluster. It's distributed by nature. It's scalable. It supports my microservices architecture. And it helps me do the container orchestration. Great. I want to work with Kubernetes. But wait. Every intro to Kubernetes tutorial is a hassle. Kubernetes is complex. It takes time to learn how to use it. It takes time to understand what to do with it. It's very complex. It's always takes time to dive in, to understand the concept. There's a lot of new concept that Kubernetes brings to the world. And like I am developer mentioned and posted online, around Kubernetes, we are open, the door is just very heavy, which means Kubernetes is open source, but onboarding to Kubernetes, starting to use Kubernetes can be sometimes challenging. So this is kind of a high level of the Kubernetes architecture. Let's say I have a user interface, and this is my app, this is my e-commerce, and it can communicate with some API that communicates with the Kubernetes masters. And I can also have a CLI command line interface to communicate with my Kubernetes masters as well, because I need to maintain it, I need to make sure everything is well. And the way it works, Kubernetes takes those requests and distribute them to the right nodes. And nodes are basically some hardware component It can be a VM hosted on a cloud, which provides CPU and RAM resources to be used by the Kubernetes cluster and to actually serve what we want to do, to serve our clients at the end. Zooming in to Kubernetes nodes, we can see something called pods. And pods can hold one or more containers, and containers that share the same pod usually share the same resources and network as well. And one pod can be in charge of multiple containers on multiple nodes, even on a different physical machines or virtual machines. But the whole idea that it needs to serve one unit of development that need to be horizontal scaling, which means I can distribute on multiple machines, and it needs to be replicated. And you can see here on the top, I have something called image registry. And the image registry holds all my images that I can later on deploy them and run them in my containers on my pods. And underneath that, I have the Docker, I have Kubelet, and some other services that we're going to discuss. So you're probably interested in, wait, how does it do it? How does it work? I mean, I'm just doing a deployment and it's there. Well, there is something called the reconciliation loop, Kubernetes reconciliation loop, and it's a constant loop that always runs. It's always measured the actual state that it's in at the moment, and it's tried to reach the desired state. Yes, with VMs, there's going to be failures. The VM is going to be down. There's going to be disconnection of the network. There's going to be a lot of other faults, but the whole idea, what Kubernetes gives us, it constantly will try to revive that specific pod, to deploy the image again and again until it succeeds. And how it deployed it? It deployed it using a file name YAML. From the type of YAML. And the YAML files give me the different spec of how I need to choose the node to run at. Maybe I have different nodes. Maybe I'm working with both Linux and Windows machines. Maybe I have certain specifications. I want to work with specific RAM or work with specific, or I need to open some specific ports. There's a lot of things I need to, Kubernetes asks me about what kind of node to pick for me, because it allows me to manage different types of nodes. So this is just an example of how we can configure Kubernetes. And here you can already see that one of the tolerations key that I asked it is something called Virtual Kubelet that we're going to touch more going forward. But it's important to understand that this is how the reconciliation works. We give it the node selector criteria that we want it to pick the nodes by, and it always tries to look for the right node to deploy it. Breaking down Kubernetes into two parts gives us, like we saw before, the master and the nodes. The master is in charge of the operation. It's in charge of something called etcd, which is a persistent database, persistent and consistent database, key value database that holds different information regarding the cluster. It holds the schedule if we need to bind pods to new nodes. It holds the controller manager and with the controller loops. And also it has API server that communicates with the different nodes. And when we look at the different nodes, we know they have to manage networking. They have to manage Kubelet. And Kubelet is a primary node agent that runs on each node. And the whole mission of Kubelet is to manage the containers that were created by Kubernetes. And also, if there were changes, it needs to deploy the new containers with the changes. And it's constantly communicate with the Kubernetes masters. There is a container runtime, and there is the OS, operation systems, underline that. And when we think about different network protocols to work with, in Kubernetes, we have multiple of them. You can look at the different arrow on the different colorful arrow on the side to get an understanding of the different protocols we work with. So how does it all starts? It all starts with a Docker file. I'm taking my app and I'm Dockerizing it. I'm giving it a Docker file with all the criteria and all the credentials and all the libraries that it needs in order to run. And then I take this Docker file, I produce an image, and I push the image to a container registry. And the container registry holds all my images for me with versioning. It's super important. I want to have versioning for my apps. I want to know which kind of version I'm going to deploy. And then Kubernetes can pull from the container registry according to the YAML file we provided it with, which tells it which container registry to go to and where to pull that specific image with what specific version. So this is how it all come together. But you're probably curious, I mean, how is all related to burst workloads, right? So if you remember in the beginning, we said we have multiple options. And some of the options seemed like they might be a good idea, and some seemed like it's too much of a hassle to manage. So one of them that seemed like a good idea was the Kubernetes cluster autoscaler. I mean, if Kubernetes can scale for me, why not let it just do it? And we can enable it when we provision a Kubernetes cluster. We can say, okay, VM scale set, I would like to enable that, and I want my Kubernetes cluster, if I'm working with a managed Kubernetes cluster in that case, I want it to be able to auto-scale when I need to. However, when does the autoscaler kicks in? Well, it kicks in when pods are failing to launch. I mean, there's a bottleneck on my clusters and pods starting to fail, and I get to 100% CPU, and I have no more RAM on my machines, and I am in a position where I don't have any more resources, and this is when the autoscaler kicks in. This is when I'm going, the other side comes in and say, okay, I'm going to provision new VMs, register them, and give you more resources. And my question is that good enough? Is that fast enough? Is that going to answer my latency issues? Well, probably not. It probably means that I might have something in between a few minutes to 15 minutes to maybe half an hour of not being able to serve my clients well. And this is an issue because that means that when I create my e-commerce system, I might lose the customers because, hey, you know, it's Black Friday and the website is down. So we just, as a customer, I can just go to a different website, right? So I don't want that to happen. I know it means I'm going to lose customers. So another option we have with a managed Kubernetes, and not only with a managed Kubernetes, we can run it on Kubernetes, that's the virtual kubelets. And the virtual kubelets are designed for us to work with burst workloads. And specifically on Azure, the virtual kubelets we are able to provision them, we're able to enable them directly when we start the Kubernetes cluster. We don't have to deploy the app to start running it because we don't need it yet, but we can enable it and enable this type of nodes in our cluster to support our burst workloads. But wait, what is a virtual kubelet, right? I mean, how does it help me? So when looking at the high level, we have the Kubernetes API. Yes, this is our Kubernetes masters, and we work with the Kubernetes API, and we have the different nodes, and we know each node has kubelet, and kubelet are the piece that communicates with the Kubernetes masters. And then there is this new thing called virtual kubelet. And virtual kubelet are not actual kubelet. They're not actual nodes. They're virtual, and we can use it however we want. It's when they start with infinity amount of resources. From Kubernetes side, it doesn't see any limits there. There are no limits. And virtual kubelets can stand in exactly when we need that support for the different workloads, for the Bursty workloads. And it's important to know that Virtual Kubelet is an open source implementation of the Kubernetes kubelet. It has multiple connectors today. It's available on multiple clusters. A lot of people implement it for different use cases. On Azure, we have it for ACI and Azure Functions and other use case. On AWS, there are multiple connectors there, and it's relatively easy to implement the virtual kubelet. There is a small interface and like 3 or 4 functions that you need to implement, and that's it. You have your virtual kubelet. And a virtual kubelet communicates with the rest of my Kubernetes clusters. So when we think about it, it's actually, we can think of kind of having a serverless cloud container platform, because we can take the virtual kubelet and connect it to other managed services or maybe other clusters, and also other things that we can do with it. So here, for example, I'm connecting it to ACI, and my ACI contains out of container groups, and in the container groups I can support my burst workloads. And I already know that when I'm thinking about cost, using ACI for burst workloads probably going to cost me less than spinning a new VM for the dedicated mission that I'm trying to achieve. And the good thing about ACI that it's pay as you go, which means however you're using, this is what you're going to pay. You don't have to commit to a whole month or a whole year, for example. So when we look at it from a high level, I have my Azure Container Registry where I'm pulling my images. This is number 2 into AKS. And AKS builds the image when it reaches a certain peak, or when I tell it, listen, now I know that there is Black Friday coming up. Please spin my virtual kubelets and start my other cluster or my ACI cluster. Then it can easily be done with an apply method and the right configuration for YAML. This is another idea of architecture of how we can work with it. So if we zoom in into AKS, into Azure Kubernetes Service, we can see that it can work with Virtual Kubelet. It can also work with Azure Cosmos DB. Maybe we have some Apache Spark workloads, some analytics that we're doing in the background. And this is basically how I can pack together also my microservices workloads and expected burst workloads that I need to support, and maybe other things that I want to support as well. So putting all of it together, virtual node or virtual kubelet allows me to connect Azure container instances with Azure Kubernetes services through ACR, my Azure Container Registry. And how do I make it happen? I need to define it. I need to define a YAML file with the right specifications to tell it, listen, now I am going to work with a virtual kubelet. So under the node selector type, we have to give it virtual kubelet. It already knows what it is. If we provision AKS with virtual kubelet, it already knows out of the box what it is. If we provision Kubernetes cluster without a managed that doesn't support managed services, then we need to add something called connectors. Using the Helm chart, we can add the connectors for the virtual kubelet. But this is just the technical part. But after we've done that, in order to give it the right specifications in the YAML file, I'm going to need to tell it, listen, under the node selector, when you're doing the node selector, on the type, take the virtual kubelet. On the ACR, the container registry, take the image that I now want to work with that supports my burst workloads. And this is the pool secret. And pool secret is super important for me because I want to be able to coordinate between my ACR, Azure Container Registry, and my ACI, Azure Container Instances. And for doing that, I'm leveraging Kubernetes secrets mechanism. And then I want to give it some tolerance for pod selections. I wanted to pick the virtual kubelet that is defined as provider. And how it's going to look like for my command line if I'm going to call to kubectl get nodes -o wide, I can actually see there that I have a new type of node named virtual node ACI Linux, because this is the type of virtual node I'm working with. And later on, when we're calling pods, and I want to get the pods and to see which kind of nodes each pod got, when I'm looking at my backend server, I can actually see that it selected the right node because I gave it the right selection criteria. So it knows it's looking for the virtual node ACI Linux. And this is how I know it all works well and connects well. And like I mentioned before, Virtual Kubelet is an open source by the community, for the community. It started in Microsoft, but now it's a lot of other companies are using it as well. And there's a lot of connectors to a lot of different clouds. And it's a super cool project. It's written in Go. So if you are a Go fans and you want to dive in, I highly recommend it to learn a little bit about how they implemented and what they did. And if you're interested in hearing a fun use case that Netflix did and how Netflix leveraged Virtual Kubelet, there is a great talk from KubeCon of how they built their Titus, their Netflix container management platform, with Virtual Kubelet, and how they leverage Virtual Kubelet for working with different workloads, such as working with Cassandra and other workloads that they need to support in their system. So I highly recommend to watch it. It's super interesting, and also part of Titus are open source. So if you want to learn a bit more about how they did it, highly recommend it. I said I'm not going to talk about security, but I have to say only one short thing. When we work with container instances and when we work with container registry, it's super important to understand the security considerations of how everything operates. It's super important to be able to scan the different images that we are deploying, and to go through the different security recommendations, because we don't want to deploy something that we don't want to run on our machines that's going to do more harm. So I highly recommend to read a little bit about containers security and how it works. It's a whole world. A lot of people are doing it wrong, but that's fine. There's a lot of tools for doing it as well. Yeah. Awesome. So I have a bunch of links for you if you want to try them out. I'm going to give you the slides. Let me see if I can share my screen. I prepared a very short demo. So just let me know what you can see. Can you see my terminal? No. Okay.
It's kind of blank. Can you reshare again?
Yes. All right. Can you see it?
It's presenting. Yeah, we can see.
All right. Cool. So I already know. I already told you that I installed Virtual Kubelet, and I have Virtual Kubelet already in my system. So this is how I know. I have basically 3 different pools of Azure Kubernetes Services node pools that I'm working with. And I have the virtual node ACI Linux that I'm working with from this version. And the cool thing is that I didn't need to run any container with Helm or any connectors with Helm and anything like that, because when I use the managed services, I told it in the portal, I asked it specifically, I am going to use virtual nodes in my cluster, so it will be ready. And when we think about pricing, this is something I'm not paying for currently, because the way the cost for AKS works is that we're only paying for the VMs that we are using. And virtual node is not running on any VMs. I am, though, paying for the other 3 groups of VMs that I have, but this is something else, and this is dedicated for something else. So let's look at my pods. All right, so I have some Kotlin with Spring app. You can look at it as like a JVM Java app that I'm running there. They're doing some stuff, exposing some UI, but I want to know which kind of node it picked. So I can see this is the virtual node ACI that I wanted it to pick. And let's do describe. I want to see. All right, cool. Yes, so this is controlled by the replica set, which means it can be replicated. There is a container ID that I get from ACI, because what it did for me, it deployed an Azure container instance for me, so I didn't need to think about it, and it's providing the ID if I want to go back and debug it and collect logs and see everything. Yes, it's populated by a secret, and there are a few tolerations there as well. But the main, for the node selector, I can see that I specifically said I want a type of virtual kubelet, and this is how it knows to pick my virtual kubelet. All right. Any questions?
Yeah. Thank you for a nice presentation. It was like awesome. You started with the basics of the Kubernetes to all over the virtual kubelet. We have questions in the doc. So let me share my screen. Okay. Is my screen visible?
Yes.
Yeah. So like we are maintaining all of those docs and questions from last meetups also on the same doc. That's why structure, so that we can go through all of those queries and discussions in the same doc. So yeah, these are the questions. So is the virtual kubelet is integrated as built-in type in Azure? What options are there for other providers, Azure and Google Cloud?
So yes, it's integrated as built-in. When I'm provisioning a cluster, let me share my screen again.
Stop.
Just a second. All right, so I'm here in the Azure portal, and let's say I want to create a new managed Kubernetes cluster. Can you see it? Do you see my screen?
Yeah. Yeah.
Okay, cool. Awesome. So there's some things I need to specify, like resource group and subscription, and giving it a name. And then giving it the region that I want it to be deployed. And also I need to pick what's going to be my primary node pool and different node sizes that I want to work with, and how many nodes I want to start with as a beginning. And then when I'm going to, from the basics, when I'm going to the node pools here, I can actually specify it and click this one and saying, I now want to enable virtual nodes in my cluster. So I don't need to do any connection manually. Once I'm giving it enabled, I'm going to see in my when I'm looking at my cluster after it's deployed, I'm going to see this kind of type available for me from the nodes. I can do the same thing with VM scale set as well. So this is how it's done when it's a managed services. Regarding the other clouds, I honestly don't know, but I know there's a lot of connectors to different managed services and other clouds as well, because Virtual Kubelet is an open source and a lot of people in the community are supporting it and adding new features, and a lot of companies added new features. So I don't know if they have this built in into how they when they deploy Kubernetes, when we deploy Kubernetes cluster, if they have it built in. But if not, you can always set a connector to it because it is supported by the community. It is something that people are using.
Yeah. So the
Yeah,
next,
so the,
yeah, please
yeah,
go on.
sorry to interrupt. So Adi, yeah, just to add to this, like we have an option to specify the node account. Uh, how is the process for like virtual nodes? Because they are virtual and we might create them based on the need, right? So how do we do about that? Like, what is the process?
Yeah. So for example, if I'm working with a container instance, is that what you? Okay.
Yeah.
So I can specify in my pod selections and all the operations, I can give it parameters into how I want it, how many, on ICI, we have something called container groups. How many container groups I would like it to support and what types of container groups, because I want to give it how much RAM, how much RAM I wanted to use and how much CPUs I wanted to use as well for every container group. So we can do it using that. And this is again something that implemented inside the virtual kubelet. It's kind of a params that we can ship into the ACI or other managed system that we work with. If it's different managed systems, or if we're implementing our own connectors through Virtual Kubelet, we have to think about that as well. What are the params that this system needs, and how we can best provide it with the right credentials and parameters.
So
Okay.
is it possible to do some custom configuration of the virtual nodes, like with SSD or the GPU instances or the disk size? Is it possible in that way?
So it depends on the service. I don't know. So ACI doesn't support SSD because it's the way it works. It's basically a container. It doesn't give us storage out of the box. But let's say I can work. Let's say I'm building an app and I know I need some SSD or in-memory fast database. Maybe I want to have Redis deployed as well. Redis is again something I need to bear in mind when I'm thinking about cost, because it has its own cost model as well. But maybe it can give me a good solution. So if I'm building, when I'm creating my code for the different apps for my Java, Kotlin, C#, JavaScript, Python, any app that I'm working with, this is on me if I want to connect to something that supports, for example, SSD. Does that make sense?
Yeah, yeah, sure. So everybody, like, if you have questions, just feel free to ask. Till then, I'm taking the third questions, like the spot instances in AWS or Google Cloud. They have some grace termination period, like 30 seconds or 2 minutes, I think. So is there any termination period for the virtual instances?
Again, what do you see on AWS? Can you repeat that, please?
Like there is a spot instance, when there is not enough resource on AWS gives some kind of termination period of, I think, 1 or 2 minutes, and after that it will turn off. So is there any something like that for the virtual kubelet?
So spot instances are usually considered something that is not can't be trusted most of the times, because once you can have it for a little time and then you don't have them. We support it in Azure. You can spin off different VMs that are built on Spot instances, but again, it's in the scenario that we shared today, it's not so relevant because I'm not necessarily want to put my app when I know there's a high demand for my products and for my e-commerce, for that example, on instances that can be taken away from me by the infrastructure. So maybe I want to invest a little bit more and use VMs that are slightly more stable, or that I know that are going to be available for me, and the infrastructure and the cloud providers guarantee that it's going to be available for me. Spot instances are fantastic for offline workloads. So if I'm doing heavy things like offline analytics, I have a lot of data and now I need to process it, and I don't care about how fast it's going to happen. I don't care if it's going to fail or not. This is when Spot Instances shines. If I have a development environment and I just want to test a few apps, or if I have a test environment, or if I'm a student and I want to learn about how to use the cloud, Spot Instances are perfect for me because it's not related. Everything that I do is not going to impact my end user at the moment. So again, it's available. And you can use it. It's not connected to, well, at the moment, it's not connected to Virtual Kubelet, because Virtual Kubelet is basically main purpose is to be used with burst workloads. But you can implement it and you can use that if you want to work with that. It's a possibility. But again, it's important to know what kind of instances you're using for what kind of workloads that you're working with. That makes sense.
Yes, absolutely. So anybody have any questions, just feel free to ask, unmute yourself and ask.
I have one question regarding the pricing.
Yeah.
As the virtual kubelets, it looks like a serverless model. Is the pricing similar to how the serverless services are charged as per the number of requests?
So the way the pricing works is you don't pay for the virtual kubelet itself, but you pay for the service that you decided to spin with the virtual kubelet. So for example, if I'm working with Azure container instances and now I'm spinning, I'm starting my app on Virtual Kubelet that I know is going to provision ACI instances, Azure container instances, then I am going to start paying for it until I'm going to turn it off. So this is where the pricing kicks in. And this is why I showed kind of an example of how we can break down the cost and why every second matters. Because when I work with Azure container instances, I'm thinking there are a few criteria that I need to bear in mind. The first one is how long is going to be up in seconds. The calculation is in seconds. How much gigabytes RAM I'm consuming per second, and how many cores, how many CPUs I need to use for my run. So this is how the cost calculates. And I'm not paying specifically for Virtual Kubelet. Virtual Kubelet, I'm kind of getting it from the Kubernetes cluster. But I am going to pay for every managed service that I'm going to spin with Virtual Kubelet. So if I'm going to spin some, let's say I want to work with Lambda or some other managed services that exist there, then I'm bounded to their cost model. So I need to know how their cost model works and then understand what I'm going to pay for.
Yeah, okay, thank you.
Thank you.
So anybody have any questions, just feel free to ask. Anyone, please?
I posted in a chat blog post that I wrote, I think maybe a year or Yeah, something like a year ago around Virtual Kubelet and how it works. It covers what we just saw today, and also a step-by-step tutorial if you want to reproduce the demo and try it for yourselves. And also links to the open source repository on GitHub if you want to look into it and try it. If you have questions that popping up, sometimes along the day when we think about different technologies, we kind of realize, oh wow, I had that question and I didn't get to ask it. So feel free to write me. You can contact me on LinkedIn or on Twitter. My Twitter DMs are always open. So feel free, if you have any technical questions, feel free to contact me and ask me. I'm always happy to help and learn from you as well on how you're using Kubernetes and what kind of systems you're building. It's always fun.
Yeah, so I have a bit of questions, not specific to the ACI, but in your experience, you have worked a lot on big data and all of that. So I want to know what are the challenges you face while running the big data related applications on container rather than the general applications, in terms of running on Azure or any of those like Kubernetes or just a container. So what are the challenges, different kind of challenges you face?
Wow, I think the biggest challenge is when working with container and Kubernetes, a lot of the infrastructure, when it was designed for stateless application that doesn't save any state. And the way we see it is because we need to, when we work with the storage, we always have to mount it. We have some temporal storage on our machine that we're losing once the pod is switched, or our container is down, or something happened. We basically lose everything we save on the files, on the local file system. So this is one of the main challenges, because some big data workloads, they kind of rely on writing to temporary files and then transferring those files into the final destination. For example, when we work with Apache Spark, it's a distributed systems. It's a big data analytics engine, and the way it works, when it distributed the task to the different machines, each machine kind of write to the temp folder and write to the file system some things, and when it conclude everything and it conclude the jobs, it collect all that information and shift it to a dedicated place, to a dedicated storage. And one of the challenges is that we can't do it. We have to specify it to leverage storage that is not temporary, that it's not as part of the VM. For example, I need to specify that now it's going to work with Azure blobs or AWS S3 bucketing. And this is something we need to tell it, and this is why there are unique operators, dedicated operators for working with big data workloads on Kubernetes. It's now up and coming. A lot of people work on this kind of operators to support this kind of cases where there's no real file systems that we can leverage. I mean, once the pod is down, we're losing all the information. We can't go back and kind of, build on top of the information we wrote. So this is the main challenge. We need to think about stateless versus stateful. What does that mean? How the different process communicate? So this is the challenges we see with big data and containers. But we're slowly moving. There's more and more workloads that are moving, big data workloads that are moving to Kubernetes with unique operators. Some challenges again, but I think it's definitely something that companies, big companies, are doing and leveraging.
Yeah, thank you.
Yeah,
So
Raju,
any,
I have a question.
yeah,
So Adi, once again, Do you guys use Virtual Kubelet? Obviously, I think you guys do inside Microsoft or Azure in your platform. And yeah, I'd like to hear more on what's your use case over there. Like, how do you manage your Bursty workload, or if you could share. So yeah.
Um, I don't think there's something specific that I can share, but basically everything that you can see online. A lot of our engineers speaks at conference like KubeCon and another big conference where they can share slightly more about that. I can say that we're doing a lot of work with Kubernetes and Spark and big data, because the cloud, when working with the cloud, we're dealing with exabytes of data. It's really huge, but I can't, I can share any specific use case. But again, I recommend, there is a great talk by Netflix, and Netflix is also a huge company processing a lot of data. I think they have more than 10,000 nodes or VMs only in some parts of the world, but um, it was some years ago that they published a number. Probably now it's more than 10,000 VMs that they're managing. And they shared their story of how they build Titus, that it's slightly similar to how Kubernetes work. And they actually leverage everything from Virtual Kubelet to connect to different workloads like Cassandra and other workloads. So this is online, and part of Titus is open source as well. So if you want a glimpse into how it works in big company, definitely take a look at the Titus and Netflix use case. And I'm going to give you my slides. I'm going to share my slides with the team, so you can take it and go over it. If there's something that you want to understand slightly more, if there's some links there, maybe you want to click the links and learn more things. Yeah.
Yeah, sure. Thank you.
Can I add one general questions?
Absolutely.
Yeah, how is it like working in Microsoft? So
It's fun. It's fun. Challenges becomes big. Before that, I worked for Akamai, and I worked with petabyte of data, and I thought it was huge, and now it's get bigger. So yeah, the challenges are big. The a lot of smart people. I always learn something new. Every day I learn something new, which is always fun. I'm always challenging myself. I always feel like I worked for other companies in the past, and I felt after some time that, okay, I already understand the system, and there's no new stuff to learn. But here, there's always new stuff to learn, and always new technology, and always new stuff, new things that comes up. And leveraging a lot of open source as well. We're thinking about cost, and thinking about customers, and if they're happy. And again, when we think about, when we decide, putting myself kind of out there, when we decide to use different softwares, like I said in the beginning, many times it's not necessarily project that starts from scratch. So we're looking at the challenge of migration, and we're looking at the challenge of migration. We're looking at the challenge of migration when there are hundreds or thousands of paying customers. So we have to be, there's a lot of responsibility there as well. So we have to be very cautious with everything that we do and how we move the system, which is very different than when we're building a system from scratch. When I'm building, if I want to build some app at home or with my friends, we can sit down and start talking about designs and idea. But once there are customers involved, the whole mindset, the whole responsibility changes, and everything that we do, we have to be, we have to know, we have to understand, or at least try to understand best what we are going to do. And there's always surprises, so we have to be ready for that. We have to be able to act and maintain the system, and yeah.
Yeah. So anybody have any questions? Otherwise, I have one. So coming like a bit far from the technical perspective or the other technical things. So personally, if you are not in front of laptop? So what are like how do you spend your time, like cooking food or traveling? So can you share about on that also?
Well, I want to travel to Kathmandu, definitely.
Yeah,
One day, when flights are back, and and we can travel again. Yeah, I like traveling. I have a cat.
nice.
Yeah, I have a home cat. She doesn't go out. She's only at home. Cooking is always fun. I like to work out as well. Again, when it's safe. At the moment, they closed all the gyms and stuff, so this is not a possibility. But yeah, this is kind of the things I like to do. I like to teach technology sometimes. So sometimes I'm teaching, I'm giving courses as well on different topics, because I'm a big believer that everyone can be taught if they are willing to put in the time and the effort to learn new stuff. And that translates to time and focus and everything around that. So this is one of my beliefs, and I'm always happy to share my knowledge with people. And now, when kind of everything is everything is remote, I can actually do it with people around the world, and not just people that are next to me, which is great. Yeah, sometimes I post funny stuff on Twitter. Funny things that I find online. Yeah, mostly it.
Yeah, we see you as an excellent speaker and presenter and teacher also, because you have a very depth overview in sort of span of bit of a small span of time also. So I think if anybody have questions, or we'll wrap up. Okay. I think everybody has good.
Yeah,
And
no
we're
question,
asking
but
something.
just comments. Yeah, it was very nice to have you, Adi. Yeah, so much learnings. Thank you for your awesome presentation. And yeah, we'd like to have you more on our further sessions regarding the things you mentioned earlier, right? Other stuffs. Yeah, thanks again.
Awesome. Thank you, Milan. My pleasure.
Okay, it's our pleasure to have you as a speaker, and we learned a lot also about the Kubelet and all of those things. So yeah, thank you all for attending. We had like 35 guests, I think, in total. That was a hit. So thank you all. And in the message section, we have a shared doc where we have shared all of those the blogs and all of those resources also, where you can drive into that. And in the questions, I will be adding a few of the answers which Adi gave, so that it will be good for reference also. And we have a GitHub repository in the same doc called Curation, where we are collecting the educational resources, all of those podcasts, blogs, and all of those things. So feel free to contribute there also. And keep on following us on meetup.com. So we'll have next meetup in 3 weeks. I think it will be on Sunday. So yeah, thank you all for attending, and thank you, Adi, for excellent presentation and giving your time also.
Thank you so much for everyone for taking the time to learn something new and joining a meetup. It's always fun. And I'm looking forward to connect with you either on LinkedIn or Twitter or any other platforms that you're comfortable with. Feel free to ping me. Awesome.
Yeah, sure.
Cool.
Okay, bye bye everybody. So have a good night, and I think we are all on good night. Yeah. Okay, bye bye.
Good
Yeah,
night.
bye.
Take care. Bye.
Yeah, thank you.